Sam.
And today with us, we have Stephen McLaughlin, a really smart guy. Can you tell us what your job is and why we've brought you here?
Absolutely. Definitely not a smart guy, though, so let me just dispel that rumor first and foremost. But what I do is I am the director of data consulting services for a company called UDIG. So we sell IT, basically IT solutions. Should I expand, or I don't know if you want me to give the whole marketing spiel. We have a lot of data geeks that do cool data stuff for people. How about that?
Perfect. This is a newbie kind of podcast, so that's a perfect explanation, I think.
Cool.
Yeah, how were your guys' days? Anything exciting in data collection land?
Nope, not here. Pretty boring. Pretty slow one today.
Well, that's good.
Yeah.
Need some time to take a breather every once in a while.
Yeah, you really do. I've been traveling like crazy the last couple weeks, so today was a welcome back to normal.
Yay!
That's good to hear.
How about you?
It was amazing. I had the first time ever, I had somebody, while I was trying to support them via phone, their fire alarm went off.
Oh, that's amazing.
And at first she was just like, oh, anyway, and continued talking about the problem. And I was like, is there a fire? Can you see anything?
Funny.
And yeah, eventually she did leave and she had to call me back later. But it was just like, no, really, if there's a fire, I don't want you to die because you're trying to talk to me.
At least she didn't call you because of the fire, right? Like, I'm not sure what that noise is. I'm going to call the help desk. Guys, there's a really loud, repetitive noise. Can you help?
Oh my god. That's great. Yeah. Is these lights? Ma'am, I think you might need a fire department.
There's like this burny smell. Flames are leaping out of the back of my computer. Is that normal? Or does that mean it's on turbo mode?
Well, ma'am, your solution is you get that fire and you put it over there with the other fire, and then you call the cop. Or the fire department, whichever one.
Sam, I understand you have some news for us today.
Ooh, yeah. I was looking up and, ingesting some news this week of different things. So, there was a pretty interesting one on Facebook actually. Facebook had a data breach, which is always fun.
Oh yeah.
Apparently affecting 90 million users,
That's
or
it?
directly affecting 29 million users, and possibly affecting 90. So yeah, so that was fun. They
But that's like what, a third of their users, maybe less.
yeah, well,
Probably less.
when a third of your users, I think it's way less than a third.
It's more like a eighth, maybe.
Yeah. But yeah, they gave some pretty interesting stuff. Basically, it includes phone numbers and email addresses and stuff like that.
Oh, jeez.
Yeah, some of them including like gender, educational background, and geolocation data.
Oh
So
my
that's
god.
fun. Yeah. They gave some pretty handy stuff out there on how to figure out if you were affected in the breach, because them sending you an email saying, hey, you were affected in the breach is a little bit too difficult. But yeah, it's located on their Facebook help page, facebook.com/help/security notice. And you can enter in your Facebook data there in order for them to tell you whether or not you were caught up in this.
Wait, so you have to go log into another site to figure out if your login is compromised.
Yeah. Well, Facebook doesn't have the resources to get the list of people that they already are pulling for this website and just send them all emails to say, hey, your geolocation data is out just in the wild.
Yikes.
They can creepily put up your whatever advertisements, but
yeah.
Do you remember when Facebook briefly included your friends' pictures in advertisements?
I do remember that. I actually know somebody directly involved in who
that was grotesque.
That?
Yeah. Technically, according to their terms of service and some current stuff, they can still do that. They just don't.
Yeah.
So.
Because it creeps people the hell out.
Yeah. But
Ugh.
Yeah, but in, less kind of, depressing news, let's see. Tesla achieved the National Highway and Transport Association's best kind of safety rating ever.
Is
Basically,
that
they
with
rated.
the 3? Sorry.
Yep. The new Model 3 basically gives you the lowest probability of injury of anything out there, right? So that's kind of
that's
cool.
good. My boss, our CEO, has one. I had never driven a Tesla, but he let me drive his, and it is. I'm not a big car guy, but holy smokes, it's really fast. I mean, it's really fast. Like, it's knock you back in the seat fast, which was pretty cool.
Yeah, no, you feel the gravity of it when you're sure.
It was awesome.
But that's really
cool.
There was some other one.
Hashtag cars, you will never find me driving in Nebraska.
Yeah, the distance between charging locations might be different for you in Nebraska than it is for me in Southern California.
Yeah.
Just a little bit.
Yeah. What else is there? Oh, some more depressing news. Google had a data breach also. Affecting
Google Plus is going away.
Google Plus, and then they shortly afterwards no more Google Plus, so that's cool.
And nobody mourned for the loss of Google Plus.
Yep, nobody. There's some AI news. Google is also claiming a 99% detection rate in metastatic breast cancer with some of their AI.
Oh.
That's cool.
So that's really cool. Basically, when put up against doctors, even in some of the most grueling situations, the doctors were getting about a 60% rate of correctly identifying it, and their AI was getting a 99% accuracy rate, which should be really good for new for people,
That's awesome.
Considering the news a few episodes ago was about how terrible AI was doing at identifying cancer and things. Apparently, they've resolved some of it.
Yeah,
this
I know.
Was a specific type. This is just breast cancer, I guess.
Yes, this is specifically breast cancer. And basically using just some standard kind of data sets, them through machine learning, actually being able to identify what is breast cancer and what is not, and determining between regular, just kind of you have breast cancer, and stuff that would further metastasize between different normal tumor tissue, I guess, that isn't cancer. So that's interesting.
Sure.
Yeah.
That's really cool.
That's really cool.
Yeah, that's super cool. That's
awesome.
That's all the cool stuff, at least.
That is really cool, and it dovetails nicely into Steven giving us a 101 on what in the world machine learning is.
Awesome. I'm happy to. I love it. All right, so I'm going off the cuff here, so feel free to just interrupt me and ask a question if something doesn't make sense.
Absolutely.
All right, we ready?
Yep.
All right. Here we go. I'm cracking knuckles right now. All right.
I am ready.
Hear it.
Yeah, they're very small knuckles, actually. Like,
there, I cracked them for you.
Thank you. I actually can't do that. I've never been able to do it. Like, I can't willfully crack knuckles. So, now you know a secret about me. That's my weakness. It's my biggest weakness.
The secret's out.
Yep. All right. So machine learning is often used interchangeably with artificial intelligence. And the terms are related. Sometimes you'll hear people say machine learning is a type of artificial intelligence. I like to think that more specifically, it's sort of an application of artificial intelligence. So I have some examples to talk through and explain kind of what the differences are. So artificial intelligence is, not as complicated as some people tend to think. It's right there in the name. It is simply something giving the impression of being smart. And we encounter this all the time, right? So a great example is not just, say, a Tesla's auto-driving capabilities, but even other cars that have, like, the auto parallel park, right? So that's a type of artificial intelligence. Right? But chatbots, right? When you go to a site and it says, hey, how can I help you? And you say, oh, I'm interested in, the security breach or whatever. They say, oh, cool. I saw that you said security breach. So, I'm routing you to this information. When it behaves in a way that you would expect a human to behave, it's mimicking intelligence, unless it's artificial intelligence, right? So that as a concept has existed for a really long time, right? You guys are probably familiar with
Sure.
Turing, right? And the Turing test and all that good stuff, which is, if a machine can mimic a conversation, then it passes the Turing test, kind of at its most basic. So that's, artificial intelligence is extremely, extremely broad. Of course, I'm talking about these very specific examples, but the idea is if it can solve problems, that humans theoretically could given time, that's artificial intelligence. So moving on to my kind of specific example here, there are things that computers are very good at, and historically there are things that they're not good at. Calculating a ridiculously complex algorithm or math problem, computers can handle that no problem. But opening up the cupboard and grabbing the jar of peanut butter, computers are really bad at that, right? So a case of artificial intelligence, or an example, might be, hey, in this cupboard that I've opened and I'm presenting to you, find me the jar of peanut butter. All right, that's kind of a complex problem for a computer, right? Like, first of all, it has to know what a jar is. And then it's got to know, okay, well, that's a box, that's a bag of flour, that's a box of Pop-Tarts. It's got to iterate through these things and identify these things and figure out, what that is. And even still, there's going to be multiple jars. So, okay, what does a jar of peanut butter look like? How do I process that in order to identify that? So the ability to successfully identify a jar of peanut butter is artificial intelligence. The process by which a machine might be able to learn how to identify a jar of peanut butter is machine learning. And so the way... Does it make sense so far?
Perfect. Yeah.
Okay, great. So there's a couple of different types of machine learning. The most common, and the one that I'm most versed in, is an artificial neural network. And so these are really cool. The math is extremely complicated, so we're not gonna get too deep into it. But the idea is, and actually the Google case of identifying breast cancer is a great example of it. If you have a sufficiently large data set, so let's pretend that we have had our computer open up 100,000 cupboards and try to pick out the jar of peanut butter. And then we also track a lot of different data about it, right? We track data about the objects it's grabbed, about the objects it didn't grab, and we say things like, okay, it's made of cardboard, it's square, it's a rectangle, it's a circle, it's made of plastic. We track all these different attributes about the things that it actually wound up grabbing, and we retain whether or not it was successful or whether it failed. And we have all this huge data set. Well, now what we can do is with this huge set of data, we can feed it into an artificial neural network. And what artificial neural networks do, as simply as I can put them, is they take that data as an input, and then they do something called hidden layers. And these layers, they really mimic the way neurons work, and that data gets processed and everything kind of gets mixed into these neurons, and they have these connections between neurons, and they start to effectively get a weight applied to them. And by weight, I mean like a signal strength, right? And so initially, the data has no idea. The new neural network, everything is weighted equally, and nothing is different, and it's a newborn baby. And then you feed it the data, and let's say the first data set we feed, it grabbed a cereal box. So we feed in some attributes. It was square, it was made of cardboard, it was tall, it contained something that was, you could shake the box and hear that it contained lots of small things, and it failed. So this was not a jar of peanut butter. So what it does is, as the data comes in, these neurons start to shift, and the simplest way I can describe what they do is they form a coefficient about these different data. Okay, so we know that cardboard is not a cereal box, so we're going to give that like a negative coefficient, right? If it's made of cardboard, we're pretty sure it's now not a jar of peanut butter. Okay. Sure. And then when it gets right or wrong, this is a type of neural network or a type of machine learning called supervised learning, where we tell it the answer at the end. We say, that's not a jar of peanut butter. So it now knows, okay, I failed, and it does a process called backpropagation, which is extremely complex. You can read about it if you want, but it's essentially right. The math behind it is these neurons slightly shift in response to the fact that it got it right or wrong, and so So these
Okay.
algorithms are constantly changing these coefficients, if you will, of the neurons. So what winds up happening is it's sort of hidden to you what's going on inside the network, and there's all kinds of things that you can do to modify the network, and we don't need to go into that, but you can add additional layers, you can remove layers, you can change how reluctant it is to learn, meaning, hey, if you were successful, how much weight does it apply to that? So there's all these different things you can tweak, but in a nutshell, it takes that data and churns through it and slightly modifies itself and is always adapting to the information coming in until it gets to where it's making a pretty good prediction. So with me so far, I know that artificial neural networks are pretty complex, but we don't need to get into the minutia of those.
So the basic concept is that in this particular format, you have the end, this is what a jar of peanut butter is, and you have the robot or what have you picking up a thing, looking at whatever it's picked up and saying, this is not a jar of peanut butter, what's different? And then making those things negatives to be like, nope, that's
exactly.
not it. Nope,
exactly.
That's not it.
Or for the ones that it does get right, there are things that we tell it, say, yep, you're right, that is what it is. And so, I'm trying to think of the peanut butter I have. It's got a red lid. Okay, well, maybe now it knows that when the color red is, associated with the lid, that should have a high coefficient. It's not the single defining attribute of peanut butter, but it combined with other features gives you a pretty high confidence, right? So over time, we discover, okay, if I'm looking at an object in a cupboard and it's got a red lid, it's a plastic jar, it's circular, it's got, a J, an I, and 2 F's on the label, and it's tannish, right?
There's only one F.
Oh, is there really?
Anyway.
Oh, I'm an idiot. Well,
yeah.
we don't even we don't buy that kind of peanut butter. My wife has discovered some.
How about Skippy?
Yeah, Skippy. There you go.
Skippy.
I'm trying to think of other brands.
I'm a Peter Pan kind of guy.
Oh yeah, I like a Peter. As long as it's crunchy, I'm happy. I don't like that smooth stuff.
Yeah, I like that crunch. I like it to get stuck in my teeth.
Yeah,
and,
me too.
Yeah.
I like to give it some texture, right?
Yeah.
So essentially now our algorithm is looking at these things in the cupboard and it's processing them each, right, one at a time, individually, obviously, probably very quickly in this example, and it's saying, okay, that bag of flour, nope, it's a cardboard bag, it's white, it's really heavy, or whatever other attributes we're tracking, and so it says, I'm pretty sure that's not peanut butter. So I'm 98.8% sure that's not peanut butter. But ooh, what's this? The circular plastic jar with a red lid that's slightly tannish. I'm reasonably sure that's peanut butter. Right, and so it learned that going into this knowing absolutely nothing about what it was looking for other than us telling it when it was right and when it was wrong. And so it was able to train itself, essentially without having it coded. So that's kind of the difference between machine learning and artificial intelligence, in my opinion. Artificial intelligence, we can train something to do something, right? Like chatbots, they can have some complex nested code to know how to respond to different questions and how to route people. But with machine learning, we're not coding anything. We're just giving it the data and we're telling it what its outputs, when its outputs are right and when its outputs are wrong.
So tell me if my understanding's wrong. So based upon it, right, you're giving it kind of input. And depending on the input, let's just talk about it like lights. A series of lights turn on, right? Right. And depending on the feedback that you give it about what it actually picked up, it then associates certain lights with a likelihood of it being that jar of peanut butter. So then when basically it's given another input, depending on what actually turns on, it can give you a degree of certainty as to how much it thinks it is peanut butter or like a jar of peanut butter.
Yeah, that's a really good analogy. The only thing I would add to that is because the neurons are essentially forming coefficients, I would say it's not necessarily that the lights are on or off, but how bright they are.
Okay.
Right?
Okay.
So one light could represent and this is where it gets complicated with the neurons, because each light kind of represents all of the attributes being looked at in a different way, which gets a little complicated to understand. But you could think about it like one light maybe is associated with each attribute. So, maybe a jar is like a medium bright light. Like, well, it's a jar, but we don't really know anything else about it. And being made of plastic is like a medium brightness, but having a red lid is like really bright. And so those things kind of combine to form essentially this coefficient.
Okay. And depending on how all those things kind of add up together, it can tell you with a certain degree of certainty that, yeah, I'm pretty sure that this is a jar of peanut butter.
Yeah, that's
Cool.
exactly right.
Very
So
cool.
in the case of the Google News article that you were just talking about, I don't know what that data set looks like, but I imagine they have a lot of it, and some of that probably includes historical data, so patient outcomes, right? They probably have,
Sure.
all sorts of maybe symptom data and maybe even scans, right? That maybe show the size of the suspected tumor or something like that. Maybe the darkness relative to the surrounding tissue. I'm just guessing here, but all of those things could be those attributes, right?
Yeah, definitely. Like with the Google data specifically, it's based upon MRI scans. So depending
Right.
on the density of the tissue, it's a brighter or a darker spot in the image.
Got it.
They were
Yeah.
feeding that in. That was their data set from.
Very cool, and I can give you an example of some projects that we've worked on, because they're really interesting, and one of the biggest uses for this is marketing. And so we worked with I guess I won't get too specific. They sell a particular product that is often viewed as a luxury item. And so what they did is they have this lead data, and they wanted to know, okay, well, what is the makeup of the people who tend to buy our product? And this tends to be targeted towards older people nearing retirement age. And so they kind of knew that stuff. But they wanted to know, given this massive amount of data, and by the way, let me just take a quick step back and say this is largely enabled nowadays by big data, right? It's the concept that we have so much data about everything, right? Including us,
Sure.
right? So companies
Yeah.
have data about you that you might be surprised to know about, right?
Like every time you go to Hy-Vee and use your little scanner card, they track exactly everything you purchased. They track how often you purchase everything.
Yeah.
If it was on sale, if you bought more, if it was on sale.
And it gets weirder than that. They actually can extrapolate data based on that. So they will say, for example, people know and sell this data. Do you live in the same city as your parents? Are your parents alive? Do they
Sure.
live there? How many kids do you have? Do your kids live at home? Like, there's a lot of extracted and extrapolated data that is used in marketing, which is a little spooky, right?
Yeah, what I find the most spooky about big data is the fact that you can get relatively anonymized data, and due to matching up factors in the anonymous data, they can then merge that into your data set in order to go, we're pretty sure that this is the exact same person, even though it's anonymized.
Yep. Yeah. And that's a big ethical concern. And that's something that, we think about a lot with machine learning and even some of the projects we work on, right? It's, you could do bad with data. We try to do good with data, and we do a lot of work. If you ever check out our website, it's udig.com. We do a lot of work in the association space, a lot of the nonprofit space. And frankly, we have a lot of clients who I can sleep at night knowing that we helped them. Right. And so far I haven't had one of those projects where I'm like, oh boy, I don't really want to do this. So I guess I'm pretty fortunate in that regard. But
Yeah, that's awesome.
But so I guess anyways, to kind of finish my example. So in this particular case, we had a huge set of data, of lead data, and then we could marry that up with whether or not they purchased this product. And so we built, and the way it works nowadays is you don't just build a artificial neural network. You can actually spin up multiple. You can spin up a lot of them. Because if you recall, they kind of start, pure as the driven snow. They've got nothing has been, no bias has been introduced, and then they sort of learn. So you can tweak them ever so slightly and have tons of these different networks all learning in parallel. Which takes us back to our pre-recording conversation. GPUs are very good at that kind of thing. And then you can see what the patterns found in those models were. So part of our project was we had, something like 100 different artificial neural networks all running in parallel. And then at the end, we could see, okay, well, this one found absolutely no pattern whatsoever in the data, but this one found a huge correlation. Sure. And some of the ones we tended towards these clusters of results, and we actually found some really interesting results from the data. And when we sort of vetted it with the business stakeholders and the people who actually were curious about it, it was panning out. I mean, it was making sense, and it was pretty interesting stuff.
Very cool. That's awesome.
And then, so the application of that is now they get a new lead in, they can score that lead, right? So they buy some lead data and they say, you know what? Kim is never going to buy this product. Right, but Steven's really into that, so let's just ignore the Kim lead, just ignore it, and instead spend our time going after Steven.
Very cool.
Right, and that would ultimately help sales and all those kind of things.
Wouldn't have to waste their effort and cut down on costs and stuff like that.
Yeah, and so it is used a lot in marketing, right? It has a huge effect in marketing, and Facebook does it, right? The ads you get are very tailored to your tastes and lifestyle. But there's a lot of other awesome applications of machine learning, just like you saw, where Google's using it to identify cancer, and it can do it better than a human because it finds patterns that humans don't necessarily pick up on. And the data we were looking at had 1,600 attributes per person, 1,600 attributes per person, and thousands of people. A human could not open that in Excel and find the patterns, right?
Well, you couldn't open it in Excel
true.
regardless.
Yeah, you would have a very, very difficult time.
Pretty sure you'd crash it. Yeah.
So that's part of what we do. And for would-be or future data geeks out there, that's the really sexy part of our job. But 80% of it before that is just getting the darn data ready to even be used in that way, right? So data's just a mess. It always is.
Right.
Let's say, for example, we've pulled that data together from multiple systems. Well, one system might refer to gender as a string, right? So it could have male, female, other as like a string, a character, right? Words. Another one could have it as a character, an M or an F or whatever, and another could have it as a digit. Older systems have it as a 0 or a 1 or a 2 or whatever. And so part of the process is, okay, well, we have to get these all to be like. We have to have them comparable. We have to. Well, this is sometimes called integrating and normalize. We have to get the data ready. Another good example is something like where you live, right? Like a city that's going to be spelled differently in all the different data. Or maybe city's a bad example, but maybe your street address, Ave versus Avenue versus AV.
Or even the fact that other countries such as Germany and Japan use completely different addressing systems where you don't even have in some cases. You just have an assigned number, that sort of.
Yeah, exactly. So a lot of the work we do is not nearly as sexy as the fun machine learning part. And in fact, as I alluded to, we kind of spun up all these different neural networks that are working. So we barely even do anything for that. It's sort of like, hey, the data's ready. Let's configure the networks. And then I think we even have auto configurators, right? So that we sort of program it all on the front end, and then it goes and spins up all these different neural networks, kind of changing parameters as it goes. So in the end, we're just, the people cleaning up the data and then interpreting the results.
Yeah, because the data set, right, is the most important thing in a machine learning network. Like basically your results will be directly indicative of how good your data, right?
100%. And thus, it's very easy to introduce biases. And we had to account for that. And in fact, I'll just share this. In the example I gave, we had to spend a lot of time, and there are mathematical and statistical ways to work around this in some ways, but we had to deal with biases because a lot of the data was broker data. And so you find that sales brokers tend to they tend to work with people near them geographically, people near them socioeconomically, right? And so there were, we noticed these patterns that we had these very strong correlations with things that we sort of, realized early on, like, well, that actually doesn't really jive, but the data clearly has a bias introduced here. And that's another thing that's common. Or you just don't capture enough data, right? So in our example of looking in the cupboard, what if we only ever captured the height of something, like maybe the height and the weight? We could never figure out what peanut butter is, right? We didn't have the right data.
Got it. Or like, for instance, if you only captured, like, say 10 cupboards, like, it probably wouldn't be able to figure out all the different details about what specific jars of peanut butter are, I guess.
Yeah, you're exactly right. You need a lot of data to train it, because it learns incrementally, right? Every row that you feed it, it only shifts it ever so slightly.
Got it. That's really interesting and kind of really important, at least in our modern kind of internet kind of ecosystem. It's the thing that kind of founds everything that runs now.
That's right. Yeah, and processing capabilities are they've come so far. The concepts behind it are really not new. I mean, I think machine learning was initially posited in like the 60s or maybe even the early 70s, the concept of an artificial neural network. And there's a lot of math behind it, but only now are we really able to do these at scale.
That makes
Super
sense.
cool.
Yeah, pretty interesting stuff, right?
Yep, definitely.
It is really interesting. A little bit scary.
A little bit, but there's good. You got to take the good with the bad, right?
Well, there's definitely good, right? Because, like, as I said, it's the at least the founding thing in our modern kind of computing ecosystem. Like, if you use anything on the internet, it's the data that they capture about you that pays for you to be able to use that free.
Right.
So
That's
other
true.
than that, people would have to, shell out actual dollars for stuff, because right now it's the data that's important and valuable to people. And, if you like using things free, then that's kind of one of the stipulations that you kind of sign up for.
Yeah, that's right. We're the product, not the customer.
Definitely in Facebook's view, that's why
Yep.
they want as many people using it as possible, because you are the product in the modern ecosystem.
Yeah.
Yeah, and there is like 2 billion users of Facebook.
Yeah,
so not even close
yeah,
to
no,
a third.
I think it's like a third of the world's population currently uses Facebook.
Yeah.
That's mind-boggling.
Something like that.
Yeah.
Isn't it? So that's why they are the best data
Yeah.
aggregators, probably.
Definitely. That's why they can advertise things to you before you even knew that they could advertise it to you.
Yep.
Oh, yeah.
Scary.
It really is. You'll be talking about something with somebody nowhere near a computer or a microphone, and then you'll get on the computer and Facebook is advertising that exact thing to you,
Yeah, that always really spooks me.
Yep. And it's not the scary stuff that people think it is, where they're listening to you. It's just that they're that good at predicting it.
Mm-hmm. Yeah, we tried to.
But it seems like
we
it's
tried to
listening.
trick it. We tried to see. I was like, all right, it's got to be a microphone, right? And so we started for about 3 weeks. We would talk all the time about something that would be way out of character for us, and we were always talking about how we really wanted to buy a crystal chess set. We have actually no interest in that. It never came up, so
Right.
I guess they weren't listening to us. Our experiment was a bust, I guess.
Yeah, for sure. Or you're somebody who's paranoid like me. All the microphones are locked down, and they're definitely not listening to you.
We would just walk around like, man, wouldn't this table look so much better with a genuine crystal chess set? Like articulating it really clearly so the language processing would get it.
Amazing.
Didn't work though.
Very cool.
Well, that's good,
Yeah.
I guess.
It works.
Very much so. Well, I feel like I have learned a whole lot tonight.
Good.
So thank you
You're
very
very
much.
welcome.
This has been enlightening. Neural networks.
Mm-hmm. They're all the
Awesome.
rage. All the kids are talking about the neural networks out there these days.
They really are, at least in my circles.
Yeah.
Yeah, and I've got to give it to you. That was one of the best explanations I've had of a neural network in ever. Honestly,
Thank you.
Yeah. Before it can get really easy to get things kind of confused in there, and I think you were pretty succinct at telling it where it's important.
I appreciate that. Like I said earlier, I'm not one of the smart guys on my team. The guys who know the math behind it, they're the smart ones. I have to be the one that translates what the smart guys are saying to business users, right? No, let me explain what he's saying here, right? I got to use like cool analogies and stuff.
Sometimes I think the translators they definitely have a different skill set. If not, maybe not more intelligent, but intelligent in different ways.
Oh man,
so.
Yeah, you're speaking to one of my favorite things when talking about artificial intelligence is, first of all, what's even intelligence, right? It's
right.
Like a whole new can of worms. There's a lot of philosophy can really kind of be wrapped up in artificial intelligence, but I think that's the topic of another podcast.
Oh, definitely. I think you can talk for hours about the difference between like a general intelligence and a very specific intelligence.
Yep.
So, yeah.
Very cool.
Well, before we dive into another 3 hours of podcasting about general versus specific intelligence, Stephen, do you have anything for us that you would like to plug?
Yeah, great question. So again, my company is called UDig. I hate the name because people don't. I hope my CEO didn't hear me just say that. Whatever. He can know because people think we're a utility, like we're like Miss Utility, like
yeah.
Like it flows too. Like, hey, don't forget to call before you dig. I'm like, well, that's not what we do at all.
Yeah,
but no, so udig.com. It's an awesome little consulting shop. I really, really love it there. My coworkers are some of my best buds, and it's pretty sweet.
Aww.
Besides that, I'm just a D&D nerd, and that's how me and Kim know each other. Yeah.
Oh yeah.
That's the best. I don't know. I didn't just out you, did I? Like you talk about your D&D life?
No.
Cool.
Yes, Sam is a fellow D&D nerd.
Good.
Yep.
He's on Beholder's Eye with me.
I didn't realize that. Awesome. And so that you can find us at twitch.tv/CastleMac and CastleMac Steven on Twitter.
Awesome.
There we go. And you can find Service Desk over on the Twitters at Service Desk Pod. The Facebook is facebook.com/Service Desk Podcast. You can email us and create a ticket in our system at servicedeskpodcast@gmail.com and find all kinds of little goodness on our website, servicedeskpodcast.com. You can also find me at Metzgirl on Twitter, and Sam, what's your handle?
Samsalot007 on Twitter.
And please make sure you rate and review Service Desk on all of the things, especially, I should have brought that up as a news article. Apparently you can game the podcast system over on Apple now.
Oh, really?
But I'll save that for another day. Rate and review us there anyway.
I'm Sam.
I'm Kim, and we're your techie friends.